So we continue with parametric equations, and we're going to use trig identities today to help us solve them. So hit pause, make some notes, and once you're ready, hit play again. We'll look at a quick example. So we have this example. It's a curve with parametric equations. X equals sine t plus 2 and y equals cos t minus 3. T is in the reals. So it says for part A, show that a Cartesian equation of the curve is given by x minus 2 squared plus y plus 3 squared equals 1. Looks like a familiar curve there. It's an equation of equation of a circle. So we want to find this equation of a circle. But we've been given x and y in terms of t. So in terms of this third parameter t, tell us that x is equal to sine t plus 2 and y is equal to cos t minus 3. We want it in terms of x and y, so I tell you what, let's express these equations. Let's make sine t here the object, so that's going to be equal to x minus 2, and here cos t is going to be equal to y plus 3. So x minus 2 and y plus 3, and they're squared. Interesting. Interesting that that's popped up as well. Sine squared t plus cos squared t equals 1. Let's just write that down here. That's a t, not a plus. Okay. So I've got sine t equals x minus 2, so I'm going to square that. X minus 2 squared plus, and it tells me that cos t is equal to y plus 3 squared equals 1. And hey presto, I've got my Cartesian equation. Okay, so if you want to hit pause, make some notes. When you're ready, hit play again. Now in the second part of the question, it says, hence, sketch the curve. Now, if I have my equation x minus 2 squared plus y plus 3 squared equals 1, the center of the circle is given by 2 minus 3, and the radius is equal to 1. Okay, this is the square root of 1, which is 1. So I can sketch that, sketch my circle. If I can draw straight lines using Cartesian coordinates, and the center is 2 minus 3, so skip across 2, drop down 3, skip across 2, drop down 3. Let's say our center is here. That's 2 and minus 3, and the radius is 1, so it's quite a small circle, a unit circle. That's job done. And if I label it then, x minus 2 squared plus y plus 3 squared equals 1. Good. It's nice and straightforward. So what I want you to do is hit pause, make some notes. When you're ready, hit play again. Right. Let's have a look at this example. Curve has got these parametric equations, x equals sine t and y equals sine 2t. And it's between the range of minus pi by 2 to plus pi by 2. So it wants us to find the Cartesian equation of the form y equals f of x, and its domain is minus k to k for x. Okay, and then in part B you've got to write down the range of the function of x. So let's get started. In the first instance then, we've got our x here equals sine t and y is equal to sine 2t. Now this is a trig identity, sine 2t is equal to 2 sine t cos t. So let's write that here. 2 sine t cos t. Now I know that x equals sine t, so I can sub it in here. That's equal to 2x cos t, which means that cos t is equal to y divided by 2x. So I've got sine t equals x and cos t equals y over 2x, and I've got my reliable function or identity, sine squared t plus cos squared t is equal to 1. So if I replace sine and cos, I end up in terms of in Cartesian terms, x and y. So let's do that. That's x squared plus y over 2x all squared is equal to 1. So let's expand and simplify. That means that x squared plus y squared over square in the bottom, don't forget, it's 4x squared is equal to 1. So let's get rid of the denominator here. So we multiply by 4x squared, multiply every term by 4x squared. We end up with 4x to the power of 4 plus y squared is equal to 4x squared. So that means that y squared is equal to 4x squared minus 4x to the power of 4. Can we factorize that? I think we can. 4x squared out leaves us with 1 minus 2x squared. That's y squared, which means that just got enough room to write y. Taking square roots of both sides, y is going to be equal to 2x square root of 1 minus x squared. That's not a 2, there shouldn't be a number here. I've taken a 4 out. I'll just rub that out. It's a little error there. There we go. Get back to my red pen. There you go. So that should just be 1 minus x squared. So that's our equation. Hit pause, make some notes, and then we're going to go on to find the domain from minus k to k. Hit pause, make some notes, and then when you're ready, hit play again. Okay, so now we want to find the domain of the function. So it ranges from minus k to plus k. In order to do that, we'll consider this function here, x equals sine t, and we want to find out the range of this value x. So x is equal to sine t. In order to find this range, we'll sketch the curve, the sine curve. If we sketch it here, this is our t and this is our x, the function. So hopefully I can draw a decent sine curve, just about. It's important we get enough room to show it. And so that's our sine curve, or sine t. I'm just going to change the color of the pen. I think it'll help. So this is pi by 2. This is pi. This here is minus pi by 2. And this is pi. Now, the maximum value of a sine curve is 1. Minimum value is minus 1. If we look between minus pi by 2 and pi, the maximum value that x can take is 1. And the minimum value that x can take is 1. Is minus 1. So our domain for x is given by minus 1 is less than or equal to x which is less than or equal to 1. That's our domain. So we've replaced k with minus 1 to 1. So we can write that in here then. Minus 1 is less than or equal to x, which is less than or equal to 1. So that's job done. Hit pause, make some notes, and we're going to find the range then of the function f of x in a very similar way. So hit pause, sketch the graph. When you're ready, hit play again. Okay, to find the range, we consider the y function, which is here. So we know that y equals sine of 2t, and this is the same domain, minus pi by 2 to t, which is less than or equal to pi by 2. Okay, so again, we do a very similar thing. We sketch the sine curve. That's our t, and this time this is y, the function. So let's sketch the curve. Hopefully it's decent enough so we can see what we're doing. Just about, I think. Okay, this time though, instead of t, we've got 2t. So everything is doubled. Let's change the color of the pen again. Sorry, I'll just write the curve y is equal to sine of 2t. Let's get a blue pen again. Right, so our range this time is from here, because that's minus pi by 2. We've doubled everything. That's pi here, 0, and that's pi by 2, and that's pi. Sorry, that should be minus pi. So if our domain stretches from minus pi by 2 to pi by 2, we're looking for the maximum value that y can take. It's going to be 1, and the minimum value that y can take, minus 1. So our range is going to be given by, let's go back to red, minus 1 less than or equal to y, which is less than or equal to 1. So that's our range, because the maximum value you can take is 1 and the minimum value you can take is minus 1 within these limits, minus pi by 2 to pi by 2. So you can write the range of the function. It's given by f of x, which is less than or equal to 1 and greater than or equal to minus 1. Job done. That's our second example. So if you want to hit pause now, sketch a diagram, and when you're ready, hit play again. And for this example, we've got the curve with parametric equations given by x equals cot t plus 2 and y equals cosec squared t minus 2, and the limits are from 0 to pi. So we want to find the equation of the curve in Cartesian form and then state the domain of x then. Okay, so first we're going to find the equation of the curve and then state its domain. So let's have a go at doing that then. So we got x equals cot t plus 2. We'll put a t in brackets because it's confusing with cot. And then y is equal to cosec squared of t minus 2. Interesting. So that means cot t is equal to x minus 2. We're rearranging it, because if I can get cot and cosec, I'm trying to think where there might be an identity I can use to help me. And then I've got cosec squared t is equal to y plus 2. Do I know something about cot and cosec? I think so. I think 1 plus cot squared t is equal to cosec squared t. So if I substitute for cot and cosec, I got 1 plus x minus 2 squared, which is equal to y plus 2. Expand and simplify. 1 plus x squared minus 4x plus 4 is equal to y plus 2. And if I simplify that, I've got x squared minus 4x. 1 plus 4 is 5, but I've got a minus, subtract the 2 on the other side, so it will be plus 3 is equal to y. And I got my Cartesian equation. And I know you're happier with it in this form. Y is equal to x squared minus 4x plus 3. So, hit pause, make some notes, and once you've done that, hit play again, and we're going to look at find the domain of x. I think we can do it on this same page. So when you're ready to do that, hit play again. Right, so in order to find the domain of x, we look at, just sketch a little line going across here. I'm going to change the color of the pen just to differentiate. We look at this function here. This is going to help us find the domain. X is equal to cot of t plus 2. So we need to sketch this function because it's running between the limits of 0 to pi. So it's cot, a normal cot looks like this, and it goes from, that's 0 and that would be pi, but in this case it's shifted, it's plus 2, so that's t and this is x. So because it's shifted up, it sort of looks like that. With the asymptote here, it gets closer and closer to the asymptote at pi, and it gets closer and closer to this asymptote here at 0. Now what values can x take in that range? Well, it tends towards 0, but it never gets there, so it gets ever smaller. But x ranges to infinity and to minus infinity, so x can take any value in the reals. That's our domain. So hit pause, and when you're ready, we're going to sketch the curve. Okay, so we want to sketch our curve. Y equals x squared minus 4x plus 3. So in order to do that, oh, I've still got blue pen, just change that. We need to find the roots. Y is equal to x squared minus 4x plus 3, which is equal to, well, it's x squared, and the roots of 3 are going to be 3 and 1, and they're both going to have to be negative to give me my minus 4x and to give me a positive 3. So x is equal to 3 or minus 1, and so we can sketch our curve then. Whoops, it's not very good. Let's try again. Go back to pen, see if I can manage a better line. Not really. Oh, we're going to have to stick with it this time. It's only a sketch. Make sure you use a ruler. It's a happy curve. It intersects with the x-axis, we know that, at 1, that's positive 1, and 3. and it intersects with the y-axis, at 3. Good. Hit pause, sketch a much better diagram than mine, and when you're ready I've got some classwork for you. And your classwork is exercise 8b. It's on page 204 in the book. I'd say left hand side and all of question 2, and then work your way down through the questions then. Okay, good. Good luck.